Hello everyone, in this video we're going to be checking the 3 practice questions that I gave you for transforming linear functions. We had this person named Pilar and she was going on a bike ride. They said that f of x is the graph of her distance from home, that's the y, and x were the hours. Write an equation in slope-intercept form, so y equals mx plus b form. The first thing we're going to need is the slope. So we should do one of the points minus the other point. So I'll do 0 minus 23 over 2 minus 0. That leaves you a negative 23 over 2, which is negative 11.5. The y-intercept, we can see right away, is going to be 23. So our function is going to be y equals negative 11.5 times x plus 23. When it asks what do the slope and y-intercept represent in context, that means you need to interpret what does the slope actually mean. The slope does the change in the y divided by the change in the x. The y is measuring the distance from home in miles, and the x is measuring the hours. What the slope is measuring, m is the change in the miles, and we're measuring by the hour, so miles per hour. Then the y-intercept in the situation is 23 miles, and it says right here, from home is how we're measuring our y's, means started 23 miles away. Which is actually a really long time, a long distance to ride your bike, unless you're like a professional or unless you just ride your bike all the time. Pilar's rate of travel on the ride can be more accurately modeled by the function g of x equals negative 8x plus 23. Okay? It says graph g of x. It said the y-intercept was 23, so that'll be one of our points. And we don't know the next point, but what we do know is that we have a slope of negative 8. M equals negative 8, which means we should rise negative 8 whenever we run one space over. Oh, I put a 9. We should rise negative 8 when we run one space over. We have the same y-intercept at 23, and let's figure out how many boxes this is. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 boxes to get to 23. It's a really weird scale. So it's like 2.5 each. Let's see. 1, 2, 3, 4, 5, 6. 6 times 2 is 12. Half of 6 is 3. Okay, so it is counting by 2.5. 5, 10, 15, 20. And then this is a little bit more than one box above. Okay, and then how are these boxes counting? If this is 3, this is 1, this is 2, then one box over should be down by 8. Another box over, another full unit over, should be down another 8. And if we connect that line through the center of all of those dots, we'll get that last intercept. And that last intercept happens just barely before the number 3. Describe the transformation. Let's look at it and interpret it. We're at the same starting point because our y-intercept was the same. We're going to end up in the same spot because we're trying to go home, but the difference is how long it took for us to get home. In the original graph, it took her 2 hours, and in this new graph, g of x, it took almost 3 hours. So it took her longer because of that. She traveled at a slower rate of change than planned, so the trip actually took her longer than 2 hours. Finally, write the equations in slope-intercept form. How are the equations related? Y equals negative 11.5x plus 23. Y equals negative 8x plus 23. How are they related to the transformation described in exercise 2? Let's look back at exercise 2. That was where we added to k. Well, we added to the f of x, or that was when we multiplied f of x. This is similar to when we multiplied f of x, but not exactly. Since only the slope changed. Okay, so since only the slope changed, not everything was multiplied. Alright, in the next videos, we'll explain how we can change f of x in a very specific ways. What are the different ways we can change f of x to make new equations and get exactly what we need to?